This is a lesson about dividing fractions by fractions. We will start with a model, and from that model develop an algorithm, which is a method to just go to the calculations. But wait, there will be more. So we will also look at fractions divided by whole numbers, whole numbers divided by fractions, and mixed numbers divided by mixed numbers as well. The first problem we're going to work with is 6/10 divided by 2/5. So I'm going to represent with a model that 6/10. So here we have 6/10. Each one is labeled 1/10. And now I'm going to divide by 2/5. So my question is, how many 2/5 are there in 6/10? Well, I know that there would be 4/10 would be equivalent to 2/5. So I need 4/10 to represent one of them. So these 4/10 go together to make 1 2/5. So far that's 1 whole 2/5 that is in 6/10. Now I have this extra piece over here, and in this extra piece I have only 2/10 left over. That's 2 out of the 4 that I need. So that would be 2/4 of what I need, therefore another half time. So together there's 1 1/2 2/5 and 6/10. So I wrote the final number sentence, 6/10 divided by 2/5 is equivalent to 1 1/2. There are 1 1/2 2/5 that fit in the 6/10 amount. The next problem we will look at is 5/6 divided by 1/2. So we're going to start with a quantity representing the 5/6. So here we have 5/6 represented, and now the question is, how many halves are there in 5/6? So I need to think about how many of the 6 it would take to make a half, and I know that 3 of those 6 would be half of a whole. So here I have 3 6 identified as being equivalent to a half, which represents 1 whole time, or 1 whole half, that I can take out of 5/6. And then the remainder over here is 2 6. It's not quite enough to give me another whole half to pull out, but it's 2 of the 3 parts that I need. So I'll record that as 2 of 3 6 that I need, and I can just call that 2/3 of a time that I can fit or pull out another half. So my conclusion, 5/6 divided by a half is 1 2/3, meaning I can take out 1 2/3 of a half from 5/6. Okay, the next problem will be 2/5 divided by 6/10. So I need to find out how many 6/10 there are in 2/5. So I will start with a model representing the 2/5. Here we have our 2/5. So now I need to think about the relationships between fifths and tenths, because I need to take out 6/10. Well, I know that 6/10 is going to be bigger, so I want to see how many I can take out. It's going to be a fractional amount. So in my 2/5, when I take all 2/5, I only have 4/10, but I need 6/10, and I just don't have that. So my conclusion is that I have 4 of the 6 parts that I need, 6/10. My conclusion then, 2/5 divided by 6/10 is 4/6. I have 4 out of 6 parts that I need, therefore there are 4/6 6/10 that fit into 2/5. So now I notice that the 4/6 can be reduced, so if I reduce it by a factor, a common factor of 2, 4 divided by 2 is 2, and 6 divided by 2 is 3. So I can say that there's 2/3 of a 6/10 that I can take out of 2/5. So the final problem I'm going to model is 2/3 divided by 1/2. So I will start with my model representing the 2/3. So here I have my 2/3, and now I need to divide the 2/3 in half. So I need to think about what's the relationship between thirds and halves. Well, 6th. So I need to create 6 size pieces. So I've divided the thirds in half so I can end up with 1/6 size pieces. 2/6 is equivalent to 1/3. Now this is not the dividing by half. I need to find out how many halves I can take out of the 4/6. So a half, is, when I'm talking about 6, is 3/6. So I need to take out 3/6 to represent half of a whole. So these 3/6 size pieces are representing a half. This is 1/2 that I can take out. 1 whole half. Now over here on the side, I only have 1/6 left. It takes 3 of them, so that's 1 out of 3 have pieces that I need to make a half. So it's 1 of 3 that I need. It's actually 1/3 of a half. So my conclusion, if I have 2/3 and I divide by a half, I can take out 1 and 1/3 halves out of 2/3. So I'm going to record what I did here in a little different way. I'm going to identify that I'm talking about 6 size pieces. So when I had my 2/3, if I record that I am doubling those, so I have 6 size pieces, I have 4/6 total. For my half, I need to know how many 6 that is, so that would be 3/6. So what I'm thinking about is I'm thinking about how many 3/6 size pieces. Everything is in 1/6, and I need 3 of them. So how many 3/6 can I take out of 4/6? Because they're the same size pieces, I'm really looking at groups of 3 when I have 4. How many groups of 3 can I make out of 4? So that's 4 divided into 3 groups. That sounds like a division problem. So I'm going to write down my thinking. I'm looking at 4 divided by 3. How many groups of 3 are there when I have 4? Well, another way of looking at that is 4/3. So I can say really what I'm doing here is I'm taking 4/3. So I included my thought here in a thought bubble. I'm questioning how many groups of 3 are there in 4. So I wrote down 4/3, and then I notice that 4/3 is equivalent to 1 and 1/3. So let's see if there's a pattern here. Let me look back at those other problems that we were doing. So the first problem we looked at was 6/10 divided by 2/5, and I needed 4/10 to make 2/5. So if I rewrite that, and so if I think about it in the other way, I'm taking groups of 4 from 6. I have 6 divided by 4 will tell me how many groups I have. And 6/4 can be reduced to 3 halves, and 3/2 is 1 1/2. So 6 things divided by groups of 4, I end up with 6/4. 6 divided by 4. Interesting. The second problem was 5/6 divided by half, and I found that that was 1 2/3. So now what if I rewrite it so that I'm showing the 6 size pieces that I had to take out, and 1/2 is equivalent to 3/6. So I had 3/6 that I needed to take out of 5/6. That's 3 groups from the 5. I ended up doing 5 groups divided by 3, and that created 5/3. And 5/3 is 1 2/3. So the third problem we had was 2/5 divided by 6/10 equals 2/3. So if I rewrite it to the equal size pieces that I used, it took 4/10 to represent 2/5. And if I divide by 6/10, I needed to know how many groups of 6 could fit into 4. 4 divided by 6 for the group size, I end up with 4/6, and 4/6 is equivalent to 2/3. Wow. So a pattern has definitely emerged. When I have common denominators, common sized pieces, I can just look at how many groups that I need out of how many I have, and that produces my final answer. So I don't really have to rely on those models, and the models can get more and more complex as pieces become larger or with denominators that aren't so friendly. So that pattern is what I'm going to be using for future problems. So we'll look at those next. So we can use this algorithm even if we're working with whole numbers. So if I have 6 divided by a half, common denominator, I have 6 over 1, common denominator is 2. So if I scale the first part, 6 over 1, by a factor of 2, I end up with 12 halves divided by 1 half. And for the question of how many halves are there in 6, well, really I'm looking at how many groups of 1 are there in 12. So there are 12 halves in 6. For the problem 2/3 divided by 5, I need to think of the 5 as being 5 over 1. Common denominator is 3, so I'll need to scale these up 3 times. No change to the first part. And then 5 times 3 is 15. 1 times 3 is 3. So now I'm looking at groups of 15 when I only have 2. So 2 divided by 15 is what I'm looking at. So there are 2/15 5s and 2/3. So the next problem is 5/10 divided by a half. So common denominator with the 10 and the 2 would be 10. So if I scale this up by 5, I'll have that common denominator of 10. Scale the numerator by 5. So I end up with 5/10 divided by 5/10. And how many 5/10 are there in 5/10? So I have 5 that I'm dividing into groups of 5. There's 1. So there is 1 group of a half in 5/10. 5/10 is equivalent to a half. Next problem is 2/3 divided by 1/4. So you can try some of these on your own. You can pause the video and try them yourself. But I'm thinking common denominator is 12, and I would have to scale this up by 4 to get my 12ths, and scale this fraction by 3 to get my 12ths. So I end up with 8/12 divided by 3/12, and I have 8 of the 12th size pieces, and I'm dividing them into groups of 3 12th size pieces. I have 8 divided by 3, and 3 goes into 8 2 times. 2 3s make 6, plus 2 more leftovers, 2 2/3. So there are 2 2/3 1/4 and 2/3. On the previous problem, I noticed that my 4th was smaller than the 2/3, so I knew that there would be more 4ths in 2/3. In this new problem of 1/5 divided by 2/3, I noticed that my 2/3 is greater. So I have a bigger amount that I'm taking or dividing from a smaller amount. So it's not going to go in there more than one time. It's going to be less than 1. I'm going to expect a fraction. My common denominator is 15, so if I scale them appropriately to get my 15th size pieces, I end up with 3/15 divided by 10/15. Now I have that confirmation that I am taking away more, or dividing into groups that are bigger size than what I have. So I have 3, but I'm dividing them into groups of 10. So 3 divided into groups of 10, I end up with 3/10. So there are 3/10 of a 2/3 in 1/5. So last problem, we'll try a couple of mixed numbers. 8 1/3 divided by 2 1/2. 2 1/2 is smaller, so I will have more than one 2 1/2 that will fit in 8 1/3. So I will expect either a whole number or a mixed number, most likely a mixed number. To do the division or multiplication, I need to divide or convert them into improper fractions. So I have 8 times 3, which is 24, plus the 1 is 25/3. For 2.5, I'm looking at the 2's and multiplying 2 times 2, I get 4. That'd be 4 halves. Plus the 1 is 5 halves total. But I need to describe them with a common denominator. With the 2 and the 3, common denominator is going to be 6. So I will have to multiply both of these by 2. For the 5 halves, I'll have to multiply both parts by 3. So 25 times 2 is 50. Over my common denominator of 6. 5 times 3 is 15 over the common denominator of 6. So I will have 50 pieces that I need to divide in groups of 15. So 50 divided by 15. I moved that over because I noticed I needed to reduce this. Common factor of 5, so if I divide both by 5, I can reduce these. 50 divided by 5 is 10, 15 divided by 5 is 3, and now putting it back into that mixed number, 3 goes into 10 3 times, that would make 9, that gives me 1 left over, so I end up with 3 1/3. So there are 3 1/3 2.5s, and 8 1/3. So I'm hoping with all these examples you'll get the hang of dividing with fractions. Thank you for watching.